Hello, Year 7, Mr. Taylor here. Today we're going to go through our character sets lesson, which is another part of our computer systems topic. This is where we're going to take our understanding of binary and really apply it to something practical with how computers work in our daily lives. So we've obviously got our keyword wall that we've been working through in our lessons. The key questions for today's lesson are going to be: what is a character set? What is ASCII? What is Unicode? And what is the purpose of ASCII? And by the end of this lesson, we're going to be able to answer these to the best of our abilities. So your first task is going to be to find this slide in your workbook. You then need to drag a tick or a cross into the boxes underneath true/false, and tell me if you think the statement to the left of it is true or false. So if you pause the video now and complete that task for me. Perfect, thank you very much, Year 7. So now we're going to go through the answers. So the first statement of binary has only two options, 0 and 1. That is true, because remember, binary is a switch. It's on or off. 0 is off and 1 is on. The binary number sequences double as the number increases. That is true, because remember, it goes 1, 2, 4, 8, 16, 32, 64, 128. It doubles each time it jumps. The binary number 1110000 would be 7 in denary. That is correct, because if we imagine a table, it goes 1 under the 1, 1 under the 2, 1 under the 4, add those together, we get 7. The largest number you can make in binary is 355. Now, in 8-bit binary, that is false, because the correct amount, the correct largest number you can make in 8-bit binary is 255. And finally, 0 and 1 represent on and repeat in binary. That is false, because as we've already covered, it represents on and off. Now, if you got any of these incorrect, you can obviously put your correct answer in the box to the right hand side. So, we're going to look now at the American Standard Code for Information Interchange. Now, that's a bit of a mouthful, so people call it ASCII. And the ASCII is what we use and what allows us to use keyboards to type into a computer. For an example of this, in binary, the letter A, the capital letter A, is 10000010. And in ASCII, that is converted to 65. So see how it's a bit easy for us to use binary and ASCII together to make it a lot more manageable and more efficient for the computer and the programmer itself, to allow us to actually understand, because if we had to read that binary numbers for every letter, it'd be very difficult. I will post this video link on to Google Classroom, but if you want to pause it and write it down and obviously type it out that way, it might be quicker for you. But I will be posting this video on Google Classroom as well for you to use, so don't worry about it. Now, after watching that video, you need to now go through this slide and write the facts in the missing boxes. So the pink boxes, the question marks, I need to write the answer. So if you pause the video now and do that for me. Thank you for doing that so quickly, Year 7. So now we're going to go through the answers. So American Standard Code for Information Interchange is the C in ASCII. All letters and characters are represented by numbers. We can see all these conversions in something called an... Oh, that one's not showing up. An ASCII table. I don't know why it came out of order there. My apologies. We use ASCII so it is easier for programmers to understand than binary. If you've got any of those incorrect, please change them now. So now we've got the ASCII table. It looks quite complicated when we first look at it, but when we break it down, it's a bit easier. So if we look on the left-hand table here, in the far left column, we've got A, B, C, D. We've got the whole alphabet, but it's all capital letters, and it goes 65, 66, 67, and obviously binary numbers on the right-hand column. And then if we go over to the right table, we've got the alphabet again in lowercase, but then we start at 97 until it goes up to 122. And then we've got the binary again. We're going to look at why these are a bit different in a minute. So why do we have each letter twice? Obviously, I've already discussed this. It's to have capital letters. Because if we had just had one, letters would obviously be boring, grammar wouldn't be correct, the way we would type stuff wouldn't be correct. And if we just had capital letters, we'd be shouting all the time, so it wouldn't be very polite if you were sending an email to someone. And then, I wonder if anyone's picked up on it now. I've already touched on it, but I wonder if anyone can remember. Can you spot something strange about this table? It's the fact that it starts at 65. Why not 1? Why not 0? Why 65? It's to allow special characters such as the at symbol, plus symbol, all the little different symbols that you guys use on keyboards, for pound, percentage, and all those are reserved for 1 to 65. So the number of 1 to 65 are used for the special characters on a keyboard. So this is the full ASCII table. This is every bit of ASCII that we could possibly need. So we've got different language letters, different symbols, different function keys on the left hand side here. So it can be quite overwhelming, but obviously we're only focusing on the base alphabet letters for now. So we're going to look at some examples. From the table in your workbook, you can obviously come back to this later if you want to, and double check it. But what would be the capital letter B on the table come up as the decimal number B? It would be 66, because remember, capital A is the first one with 65, so B would be 66. Lowercase o, now what would that be? That would be 111. The number 1, what would that be? That's a bit of a curveball. That would be 49. Z or Z, depending on how you say it, 90. Because obviously it's a capital letter and it's the last one in the alphabet, so it's the last one before, so it's 65 to 90. Lowercase z, 122. 9 is 57. The numbers could obviously be a bit confusing because how can 9 be 57? It's just how it is on the keyboard and how the computer understands how to display 9. And understand that when you press the button 9, you are actually telling the computer 57 to then convert it into binary so it can understand what you're telling it. Lowercase j, 106. So, if we want to take a name, obviously you can't be doing. You can do this in your home now if you want to grab a piece of paper. Take an A4 piece of paper, fold it in half. On one half, write your name in binary, and on the other half, write it in ASCII. And then this will allow you to see how it all works. So we've got an example here of Hannah, and the middle. So we've got the letters at the top, and then in the middle of the row we've got the binary, and then we've got the the ASCII code, the kind of denary number for it at the bottom. So the way ASCII kind of works is you type in a word such as the computer looks at the value of what kind of letter you're telling it. So if you press a letter T, capital T, it goes, you've actually told me 84, so I need to actually convert that into binary and then convert it back to put it onto your Word document as the letter T. H is 104, E is 101. The computer saves this in its memory as binary and obviously uses it as accordingly to display it appropriately so you know what you've done. Now, your task now will be to decode the message. So, using the numbers, just kind of like we did with the binary and denary conversions in the last lesson, you'll be looking at the numbers in the top boxes, finding the correct letter, and put it in the boxes below. If you pause the video and do that task now for me, that'd be perfect. Thank you very much for year 7 for doing that. So if you've done it correctly, this is the answer. The correct answer for the cut message would be computer science is amazing. Now, I personally think that's true myself, and I know you all agree. But if we look at how it all works, so the first letter is 67, and if we look for 67, that's a capital C, so that's correct. And obviously, we can just look at the number, find the letter, and that's how the computer does it. It has the table, it looks for the letter, finds the number, puts it in, saves it in the memory. Now, your next task, I want you to create your own message. So, just like in the slide before, using the whole number in the box, I want you to write down a number in this pink box. Make sure it makes sense. Try and keep a word to each row. Make it just a short message like I like football or something like that. It doesn't have to be overly complicated. So if you pause the video and do that now for me, that'd be perfect. Thank you very much, GSM, for doing that. Now, one of the final tasks will be for you to make a different message or make the same message again in binary. So you can use the message from the last task, but in this time, instead of putting the decimal numbers, so the like denary numbers in the pink box, you'll be putting the binary numbers in the boxes above. So if you do that task now. So now we're going to look at what was the problem with doing it in binary. Like I know, if we've done this in class and when I've done it with other years, it can take a long time with binary because you've got to look at each number and the number. Sorry, I'm back. So we're going to look at the problem. What was the problem? And so as I was just saying, then the problem was binary took a long time to process. You've got to look at a lot more numbers than you do with a decimal or ASCII code system, the denary number. And that's why we use ASCII. It's a lot quicker for the programmer, for the computer, and everything involved to just shoot the numbers across, get them converted, turn them back into letters, and put them on the screen for us to use. So, what I want you to do now is do a bit of research. I want you to, in this box, on your workbook where it has the ticks, I want you to explain why is ASCII better than binary for programmers. Give me 1 or 2 points, or if you want to write a bit of a paragraph, obviously Google it, do your own research, see what you can come up with. I'm interested to see what advances you guys already think there are, what you can find out. That would be really interesting to see. Now, this is one of the problems with ASCII. Here is the Chinese keyboard. So it kind of looks like our keyboard, doesn't it? Similar layout, similar buttons. We know how to use it. But if you look here, it's got the English letters of Q, W, E, R, T, so this QWERTY layout. But it's also got other symbols on it. That's because the Chinese language has many, many different characters and, in essence, letters for what they want to say and how their words and language is constructed. So they actually need kind of like a layered keyboard. So whereas our ASCII system is only is built for a single letter, theirs needs to have multiple layers. This is the drawback of ASCII. It's very limited in what it can do. It doesn't really accommodate other languages. So now you need to write that down for me in this slide. What are the disadvantages of ASCII? So now we're going to look at Unicode. On this slide in task 4, here is this box, and I need you to read it, reduce the text to make it a lot more easy to understand. Try and get it down to 15 words. So the definition of Unicode as it is now is the Unicode standards provides a unique number for every character, no matter what platform, device, application or language. It allows communication between communication platforms. So the Unicode gives a unique number and value to every character and letter, no matter what you're using it for. So it's a lot more versatile, a lot more flexible in a sense. So again, I'll put this link into Google Classroom for you to use, but if you want to pause the video and write it down and copy it and paste it, that's perfectly fine. But you're going to be doing that now. So you're going to be researching what a character set is and putting a definition into this slide for me in your workbook. So if you pause the video and do that now for me. And that's going to be it, year 7. Thank you very much for doing all the tasks as fast as you can. Obviously, if you need any more help, message me or your teacher on Google Classroom, and we'll always provide help. But I hope you're all doing well, and I'll see you all soon.